Good morning and afternoon. I'm the MC for the 2021 Korean-German Standards Conference, Yoon Hee-jung. It's a pleasure for me to meet you today. Today's conference has been organized to strengthen standards cooperation with the leader of the fourth industrial revolution, the country Germany, the powerhouse of materials, parts, and equipment. Since 2019, cooperation has taken place in the areas of smart manufacturing, future of mobility, and this year, a new area for standardization in the battery sector has been added, setting the stage for discussing bilateral technology and standardization between Korea and Germany through this conference. This conference aims to bring Korea and Germany together in sharing their national standardization strategies and delving into cooperation measures for standardization in our industries, with a view to providing a foundation for future competitiveness based on bilateral standardization cooperation. This conference is being held in strict compliance with the government's COVID quarantine guidelines. This conference is also being broadcast online, drawing in keen interest from our viewers and experts in Korea and Germany. Thank you for your participation. The Standards Conference will begin with the opening ceremony, followed by keynote speeches from Korea and Germany on technology and standardization, as well as technical presentations. I will then first invite Administrator Sang-Hoon Lee of the Korean Agency for Technology Standards for his opening remarks to commence this conference. Please come up to this podium, Administrator Lee.
Good afternoon. Ladies and gentlemen, I'm Sang-Hoon Lee, Administrator of the Korean Agency for Technology and Standard, we just call it KAT, under the Ministry of Trade, Industry and Energy. First, I'd like to extend my appreciation to Martin Henkelmann, President and CEO at the Korean-German Chamber of Commerce and Industry, for gracing today's conference with his presence despite busy schedule. Thank you very much. And I would also like to express my gratitude to Myung-Soo Kang, Chairman of the Korean Standard Association, for helping us holding this wonderful event. I'd like to express my deep gratitude to Dr. Henning Kagermann, who is delivering a keynote from Germany, and Sunun Han, professor at the Korea Advanced Institute of Science and Technology, who will be giving a keynote on behalf of the Korean side. I would also like to send my special thanks to the experts of Germany and Korea, who will be giving technical presentations at today's conference. As we enter the post-COVID era, the world is rapidly transitioning to the digital economy. We need international solidarity and cooperation to gain a global technologically competitive edge. Cross-border cooperation on standardization is becoming more important than ever, and the importance of a standard for basis of global supply chains has increased. Germany, which is a powerhouse in technology related to the fourth industrial revolution, as well as materials, parts, and equipment industries, is one of the most important partners for Korea's cooperation on international standards. Standardization cooperation between Korea and Germany is becoming even more significant in the digital transformation and climate change that is accelerated. After the pandemic, I believe that Korea and Germany should strengthen their cooperation more than ever. I'm sure standard cooperation would act as the bridge between the Rhine and the Han that can connect two countries, thus keeping the flow going constantly. I believe that the standardization technology in the field of future of mobility, smart manufacturing, and battery discussed in today's conference will serve as an important foundation for the industries of the both countries. Korean and German experts, you are at the center of the standard cooperation of the two countries. The Korean Agency for Technology and Standard, KAT, will do its best to develop standard and join actively in the international standardization based on cooperation with you and Germany. I'd like to express my gratitude to you for taking time out of your busy schedules to attend this event, and to those for participating in this event virtually from Germany and Korea. Dankeschön. 감사합니다. I wish you all the best. Thank you very much.
네, 감사합니다.
Thank you very much, Administrator. That was a warm opening remark for the participants of the event. He also talked about how we should work together to promote our technology development in terms of standardization in the post-COVID-19 era. We're providing simultaneous interpretation services. Korean is being provided from Channel 1 and English from Channel 2. Please use the receivers in front of you.
And channel 2 is English. Thank you. 자, 그러면 계속해서 다음
Let me
모시도록
continue on
하겠습니다.
with our next speaker from Korean Standards Association. Chairman and CEO Kang Myung-soo will come up to the podium for his welcome remarks. Please welcome him with a big round of applause.
Good afternoon and good morning, ladies and gentlemen. I'm Myung-soo Kang, Chairman and CEO of the Korean Standards Association. First of all, I would like to thank Administrator Lee Sang-hoon of the Korean Agency for Technology and Standards for hosting this 2021 Korean-German Standard Conference. I would like to express my sincerest appreciation to the CEO Martin Henkelmann of the Korean-German Chamber of Commerce and Industry for enlightening this conference with the remarks. Also, it is a great honor to have Dr. Henning Kagemann and Dr. Sun-Hung Han as keynote speakers on technology and standards initiative. The leading country of the Industry 4.0 and digital transformation, the nation with hidden champions, the small but strong enterprises armed with technology competitiveness and innovative mindset, the powerhouse in manufacturing and new technology. There are all different descriptions that refer to Germany. Germany is South Korea's most important European trading partner with a bilateral trade volume of $29.1 billion in 2020. Since resuming diplomatic relations in 1955, we have accumulated much experience and made substantial progress in the various aspects of the economy. And I believe that the cooperation in standards through Korean-German Standard Dialogue, which was initiated in 2019, can further deepen and broaden this economic cooperation. We are still in the long tunnel of continuing pandemic without knowing when it will over. But at the same time, we have seen the development of digital transformation. Digital transformation is a key element that enables both the digital economy, which has brought more value to existing industrial structures, and the virtual economy, which has surfaced as a new paradigm in the COVID-19 era. It is the standard that has opened up this digital transformation era, as a standard is the criteria for allowing the the technology such as IoT, artificial intelligence, to be super connected, super converged, and super intelligent. Also, in the world where industry boundaries are broken and everything is connected, standards are the key to ensuring compatibility, interoperability, and scalability. Against this backdrop, for us to effectively respond to unpredictable emerging global crises and ensure sustainable development in a digital transformation era, we need the types of international solidarity that standardization can bring. In this regard, our ability to work together towards a common goal, especially in the face of crisis, has been more relevant and vital than ever. Experts between two countries have actively engaged in the collaborative works in standard development in the field of smart manufacturing and the future of mobility since the first standards dialogue. Now, the only thing left to do is to generate a rich harvest in practicable and concrete ways, and in particular, will capture the essence of our bilateral cooperation, making the ties robust through standard cooperation and the way forward. I'm very pleased to welcome all of you who will continue the discussion on ways to further enhance the cooperation between the two nations. I firmly believe that this conference, which is the effort to bolster tangible cooperation, will add momentum to our relevant activities in standard development as we successfully embarked on the mutual collaboration platform. Having said that, I hope that this conference can be fully availed as the opportunity for experts in two countries to share their knowledge on technology and experiences in standardization and find the way going forward together. I wish all the best to all participants from Korea and Germany and hope all of you to be safe and healthy. Thank you.
네, 말씀 감사합니다. DT 시대에
Thank you very much. So the key point is standardization in this digital era. So for continued standardization, he emphasized the need to further our cooperation. Last but not least, we're going to invite CEO Martin Henkelmann of the Korean-German Chamber of Commerce and Industry, AHK Korea, for his congratulatory remarks. Please come up to the podium, sir.
Mr. Sang-Hoon Lee, Mr. Myung-Soo Kang, Dr. Sung Hong Han, Dr. Henning Kagermann, dear experts, speakers, participants online and offline, ladies and gentlemen. On behalf of the Korean-German Chamber of Commerce and Industry, I would like to congratulate the organizers, CATS and KSA, on hosting the third successful Korean-German Conference on Technology and Standards. Representing the German business community, KGCCI has been promoting economic and business relations between Germany and Korea since its inceptions in 1981. Therefore, KGCCI is very aware of how crucial the cooperation on standards is for strengthening the bilateral trade between the two countries. In fact, providing information on local standards is an integral part of our market entry service for German companies. Standards can be a key to make things easier. However, standards can also be used as an obstacle to trade, as we have seen and still see around the world. As highly industrialized and technologically advanced countries with strong export-oriented industries, both Korea and Germany can only but benefit from defining and implementing global standards. I see many interesting fields of collaboration on today's agenda, such as industrial automation, smart manufacturing, digital and circular economy, batteries, cybersecurity, and other innovative technologies. To fully capitalize on these technologies, businesses in both countries see the imperative of close collaboration from the very beginning. This will enable firm economic exchanges and research cooperations between our two countries and industries. Additionally, and I would like to point this out, the standards defined and agreed on by our countries and their industry stakeholders will apply criteria of market-driven and open economies and of export-oriented industries. These criteria will have a much stronger impact when voiced jointly by Korea and Germany in the international environment, where we see currently powerful trends to less globalization, less open market, less rule-based trade. Conferences like this provide a platform to foster the sharing of knowledge and best practice, which is why I'm excited to see many leading Korean institutes and companies, as well as Siemens and the VDE Institute, at today's conference. We need strong academia and industry involvement to define the right, the adequate, the appropriate, the open, future-oriented standards to shape our future technologies. Ladies and gentlemen, I would like to express my sincere gratitude to CUTS and KSA again for hosting this event. Many thanks also to the presenters for sharing their insights and their knowledge. I wish us all a fruitful event. Thank you very much. 감사합니다.
네, 말씀 감사합니다. 네, 미래 기술을 위한 표준화에 대한 논의를 오늘 심도 깊게 펼치길 바란다는 말씀해 주셨습니다. 고맙습니다. 네, 한국과 독일의 기술 표준화를 위한 한독 표준
Standardization cooperation. So this conference is now going to move on to the keynote presentation session. Let me make an announcement once again regarding interpretation services. Korean is being provided from channel 1 and English from channel 2. Please wear your receivers as needed.
Channel 1 is for Korean and channel 2 is for English. Thank you. 자, 그러면 첫 번째
Now, with that, we're going to invite to the stage our first keynote speaker, who will speak about Korea's standardization strategy for smart manufacturing and Korean-German cooperation. Professor of Mechanical Engineering from KAIST, Dr. Han-Sun Hung, will deliver his keynote lecture. Please welcome him with a big round of applause.
Good afternoon, ladies and gentlemen. I understand that there will be simultaneous translation services available today, so I would like to speak in Korean. Is the interpretation provided into German? Maybe yes. I prepared my presentation materials both in Korean and English. I used a mix of Korean and English. On second thought, I should have translated it into German instead of English. My apologies for that. I am working at the Korea STEP Center and also at the KICON, K-I-C-O-N, and I am also teaching at KAIST, which is a university in Korea. And I am also serving as a convener of the ISO TC 184 SC4. Today, I would like to talk about standardization status related to smart manufacturing in Korea. And at the same time, I also would like to introduce to you ISO TC 184 activities in Korea. Afterwards, I would like to also briefly touch upon the potential areas of collaboration between Korea and Germany, including the fields of digital twin brownfield, PLM MES interface, smart manufacturing, as well as reference model. Smart manufacturing reference model, excuse me. In Korea, related to smart manufacturing, about 2 years ago, there has been a change. the Ministry of Commerce, Industry, and Energy used to be the driver of smart manufacturing, but now it is being driven by the Ministry of SMEs in Korea, which reflects the government's commitment to drive this change, mostly amongst small and medium-sized companies in Korea. And as you can see here, previously there was this organization called the Korea Smart Factory Platform, but now the main driver of this change is the KOSMO, KOSMO, which is the Korea Smart Manufacturing Office. Moving on to the next slide. Regarding the status of standardization related to smart manufacturing in Korea, there is a position that's called the National Standard Coordinator. Mr. Choi Dong-hak is currently serving as the NSC of Korea, and he is driving the activities of 4 working groups that include smart factory, process model, industrial data, for which I'm responsible, as well as security. And I am also showing you relevant international organizations for each of these working groups. Related to smart factory in Korea, these are the Korean standards that have been developed so far. In 2016, we came up with a smart factory, basic concepts and structure, terminology, and operation management systems. One of those that we developed at the time was KSX 9001, which was about smart factory maturity level. If you look at the table below, there are 5 different levels, no ICT at all, and 1 level upper than that is basic, and 2 intermediate levels, and the highest level is the advanced level. So we will be evaluating the smart factory maturity levels of each of the companies so that we can tailor our assistance and support to those companies in building smart factories. We also came up with the Smart Manufacturing Deployment Guideline as one of the KS standards. And most recently, in 2021, we have made data model and management schemes for manufacturing business data interchange. Now, to briefly talk about the data interchange between manufacturing enterprise business systems, which is KSX 9101, in companies, especially in SMEs that are engaged in manufacturing, business data should be exchanged when needed. And this is about data models and management schemas to make that happen for SMEs in Korea. Now that we've created standards, we came up with some pilot tasks to be implemented across the field. We started implementing this in April 2021, and this will last for 3 years. We will focus on KSX 9101, mostly in SMEs regarding the interchange of manufacturing data. The next slide is basically about the same thing, pilot implementation. As you can see here, we are doing KSX 9101 pilot implementation. We are also trying to expand the implementation of standards. And currently, what we are focusing on in our pilot implementation are 4 sectors: automotive, electronics, shipbuilding, and parts and materials. And providing the guidelines for doing this is extremely important. And this may be slightly a different story. I understand this is something that both Korea and Germany are working together on, based on IEC 62443. This is about smart factory embedded device security. I understand this is one of the collaborative projects between our 2 countries. This has been my presentation regarding the standardization activities related to smart manufacturing. And I would like to now narrow the focus down so that I can take a deeper look into the ISO TC 184 activities in Korea. There are subcommittees 1 to 5, and I belong to Korea STEP Center, and there is another institution called the KOIA, which is the Korea Industry Intelligence Asian Association. They are driving these activities. And there is a COSD as well, which is a cooperating organization for standards development. So for each of the industrial sectors and technology areas, we have established relevant bodies who can work on standards development. This slide shows you the organization for ISO TC 184 SC4. There are subcommittee 1 and 4 and 5, and working group 6 is a separate organization, and I mostly work at SC4, which covers industrial data. Next slide is about ISO TC 184 SC4. This is a capture of the screen of the homepage of ISO TC 184 SC4. When you think of a subcommittee, you might think of it as a very small organization. But as you can see here, currently, this subcommittee has already completed publishing 785 standards, which is a huge number. I understand that maybe this number is higher than the number of standards that have been developed by a technical committee. Moving on to the next slide. I'm afraid that you do not have these slides in your booklet because I've added these slides at the last minute. This is a homepage of the K-STEP Center, and this is a list of the Korean standards that we are currently maintaining. And of course, you can see the same list by going to the CAT's homepage and other organizations, but I wanted to share this with you. And this is a screenshot of the activities that are carried out by the KOIA. There is an explanation regarding COSD, and KOIA is currently responsible for IEC TC 65, which is related to industrial process measurement, control, and automation. Korea and Germany can work together in smart manufacturing fields, and I could come up with some specific areas of collaboration, which include a digital twin brownfield, PLM-MES interface, and smart manufacturing reference model. And Gaia X Hub is already established in Korea. And I understand this is the first overseas Gaia X Hub that's established outside the EU region. Moving on to the next page, this is related to the digital twin-related activities. DIS 23247 refers to the last step of the standardization process. And I am working at the Working Group 15, and this is something that is being driven by ETRI, which is a research organization in Korea. Moving on to the next slide. Again, this is the same SC4, but this is something that is being driven by JTC1 SC41. Actually, that was the ISO CDTR 244464, which is visualization elements of digital twins. And what you are seeing right now is the Internet of Things and digital twin, which is ISO IEC JTC1 SC41. So this is a new name that we have assigned. Korea is taking an active part in the activities in this field. Of course, Germany is also taking an active participation in this area. Now, let me talk about a brownfield, which is one of the potential areas of collaboration between our two countries. SAP is often called SAP, which is the largest German company that sells ERP packages across the world. And this is a slide that I borrowed from SAP. They are using the terms such as greenfield, bluefield, and brownfield. If you go to a site where they are implementing smart manufacturing or smart factory, there are a lot of SMEs that do not really implement IoTs. And those sites are called brownfield by SAP. And greenfield refers to the most advanced factories where IoT technologies are already implemented. In Korea, there is a wide spectrum of companies, starting from all the way from the old brownfield to greenfield sites. Even within one factory, there could be some different sections of the factories with different levels of technology advancement. We need to consider all of these in implementing smart factory. I am basically talking about the same thing in a different shape. As you can see here, there are concepts of greenfield and brownfield, and we do need a transformation for us to be able to support and implement a smart manufacturing. This is a new topic that I'm trying to address today. When you go to smart factories, PLM is implemented most of the time. This is mainly about engineering and design, a software that's used by engineers. ERP is a software that's used by business managers. And you can find this package not just at manufacturing sites, but also at banks and other types of corporate institutes. As I've mentioned already, SAP is the largest ERP package provider in the world. And factories, of course, use such ERP packages. And MES is software that is used by companies that use machinery. So these three different packages of software comprise the software packages of a smart factory. About 20 years ago in Korea, ERP and 3D CAD have been deployed at SMEs at the initiative of the government. And about 10 years ago, CLM was the package that was promoted a lot, and a lot of Korean SMEs started to implementing CLM packages. And recently, our focus has been shifted to MES to be able to support smart manufacturing and smart factory. In the old days, I talked about mass production before. So in the old days of mass production, of course, we're also doing mass production these days as well. The data flow was linear, but in a to-be scenario, in a future scenario, the data flow will be personalized. And under those circumstances, the engineering department and the manufacturing department need to interchange their data more closely. And in the old days, there was no interface between those two sections, but now we do need such an interface. Again, this is a new slide that I added at the last minute. I'm sure that you're familiar with this slide, but some of you might find this very new. So in the fourth industrial revolution, we are moving from mass production to personalized production. As you can see here, this curve will move, and At the top is mass production. 1965, is it? Or 1955, right? If you go down to the bottom, of course, there are different curves, but we are moving towards a personalized production. Moving on to the next slide. To repeat what I've already talked to you previously, the Korean government has been taking the initiative in driving factory automation. About 20 years ago, their focus was on ERP and 3D CAD. And about 10 years ago, they focused on PLM. And now their focus is on MES, on the software side. It takes a lot of money to install such software. So those have been the national initiatives. Between ERP and MES, I'm sure that you can remember regard. If you go to the manufacturing fields, there you can find only ad hoc implementation in establishing an interface between these two systems, PLM and MES. Siemens, I'm sure that you know this company. Again, this is a German company. And as you can see here, in the green box, there's a PLM, and in the middle, there's MES. And as you can see here, there's already a commercial software package that's available from companies such as Siemens, but we do not have an international standard yet. But I'm saying that there is a need to develop one. Last area of potential cooperation is reference architecture model for Industry 4.0. You can find this name in small letters, Dr. Christian Mosch. And he came up with this diagram of this reference architecture that was made public several years ago already. And I understand that there are efforts currently underway to develop such a reference architecture model. And this looks slightly different, but this is again a proposal from the K-STEP for reference architecture model again. That is the reason that I see that this is an area of potential cooperation between our two countries. Korea STEP Center is where I am currently working. And there is another institution called the ProSTEP, which is German version of STEP Center. Most big countries have STEP centers, but to my knowledge, the biggest STEP center in the world is ProSTEP Center that's in Germany. And K-STEP Center has been benchmarking ProSTEP of Germany. And as you can see here, we are starting to collaborate between our two STEP centers, which can be good news for promoting our two countries' collaboration in standardization. Next slide. Again, you do not have this in your booklet. This is a photo of a Korean subway train. I'm sure that the German participants who are sitting in this ballroom must have used subway, but as you can see here, most people, probably except for one or two, are looking at their phones, smartphones. Maybe they're watching TV shows, movies, or talk shows, or maybe they're using their instant messaging services. Anyways, all of these people are doing something on their phones, which means that a lot of communication is taking place inside a subway train. Including myself, most people are using their phones inside these subway stations, mostly for entertainment purposes, but sometimes they do their work with their phones inside a subway station and subway trains. And I share this with my German friends. When it comes to pilot implementation, I believe that Korea offers one of the best environments. Thank you so much.
교수님 잠시만 기다려 주시면 감사하겠습니다. 이어서 Q&A 세션 진행.
Thank you very much. We would like to have a Q&A for the first keynote speaker today. Please raise your hand if you have a question. We'll bring you a microphone.
계시는데요. 네, 지금까지 우리나라의 스마트 제조
Yes.
현황과 함께
Regarding the current status of standardization activities in Korea, the Dr.
주시면 감사하겠습니다.
Han gave a good speech. Good afternoon. My name is Park Hee-jin from the KSA. Thank you for your presentation. When it comes to smart manufacturing innovation, data compatibility and interoperability appear to be very important. Of course, this is something that's applied not just to smart manufacturing, but with the faster development of technologies, I am sure that the data compatibility standards and standardization might be lagging or might not develop as fast as possible, which could hinder technology progress. So in that case, regarding the possibility, can you give us some advice regarding the standardization of smart manufacturing and technology growth? How can we go together or make them balanced? I used to teach engineering at a university, and I myself have been developing technologies myself as well. When it comes to patents and publication of articles in famous English journals, I do have experiences. I had to meet a requirement to graduate my university, which was publishing an article on a scientific journal. So I did all of those, developing technologies and writing up journals. There are many similarities. If there is a new technology that's developed, then you need to apply for a patent. And when it comes to standards, technologies should be stabilized, and then a lot of people believe that that's the time when you need to come up with a standard. That used to be the old way of thinking, and maybe some of you still have that type of thought in your minds. But as you've mentioned, in some cases, the technologies might move faster than standards or standardization activities. But here's the problem. Before everything becomes stable regarding technology development, because when you develop a technology, a lot of activities take place at the same time. For instance, if you think of 5G or the cable jacks that you link up to your mobile phones, there are different types. So you cannot wait until you reach the stable completion of a technology. I believe that tech standards could compete with one another, and they need to go hand in hand with technology development. Thank you very much. Standards probably need to have some good competition as well. I would like to thank Professor Han for the keynote presentation. Please give him a big hand. Thank you.
네, 감사합니다. 자, 이어서
Thank you very
인더스트리
much.
3.0의
The pioneer of Industry 4.0, world-renowned scholar from Germany, Dr. Henning Kagemann, a former president of National Academy of Science and Engineering, will deliver his keynote speech on the theme Co-creating a Digital and Circular Economy. He will join us online for the lecture.
Hello? Hello?
Hello, ladies and gentlemen. Good afternoon. I want to speak today about some topics we are doing in Germany in order to extend the scope of Industry 4.0. And you can imagine that this year, where Industry 4.0 celebrated its 10th anniversary, that people started talking about if it's time to launch the next level. That means to move to Industry 5.0. You can imagine that was a big discussion, in particular in Germany, and we all agreed unanimously in the steering board of Industry 4.0 that this would not be a good move, because the fundamental mission of Industry 4.0 hasn't changed. And that's why I want to remind us that despite the crises we have seen in the last 20 years, which are always good opportunities for innovation, we have always confirmed the strategic directions, but yes, with adapted priorities. Let me remind you to the dot-com bubble that burst around 2000, where we all learned that the advent of the internet is, let's say, moving us into the direction of building business ecosystems, which is a hot topic these days, but technology was not mature yet. On the other side, we learned that digital business is bimodal, and we experienced the importance of technology platforms and digital exchanges, which we see today in particular in projects like Gaia-X and others. In 2010, we had the economic crisis, and that was indeed the reason to launch Industry 4.0, because we felt that we miss a kind of agility and strategy and execution. And Industry 4.0, as you know, is all about adaptability, using newest digital technologies. And in a second step, we ask ourselves what would be the business model of the digital economy, and this is all around smart services. So this is still valid and is still something we are working these days, but with the pandemic, which was to some extent a societal crisis, the topics of sustainability and resilience came more into the priority list. And in addition, the question about digital sovereignty refreshed the ideas around how open data ecosystem could be built. Now, let me shortly look back to the original mission of Industry 4.0 as it was stated 2011, and it reflects already the three dimensions of sustainability. Now, we want to improve our economic situation by, let's say, new value-generating processes, by improving adaptability and productivity. On the other side, there was already an environmental aspect in it. You can see here that our intent was to bring in particular the efficiency in resource and energy consumption up to a factor of 50%, and the topic of urban production, so having production, clean production closer to where employees live, was also a hot topic. These days that has been extended, and I will cover it into a concept which is called circular economy. And if you look to the social aspects, we all hoped at that time that we could create new jobs by moving, in particular, manufacturing from offshoring more to onshoring, and that the, I think, drive towards highly automated and autonomous systems will help us in terms of social inclusion. So at the end, that we come for the employees to a better and more meaningful work. Now, in 2011, the term Industry 4.0 was coined. In 2013, we gave our recommendations to Chancellor Angela Merkel. And 2 years later, our government in Germany has established this platform, Industry 4.0, which should in particular support international cooperation, which is important in terms of standardization, but also to support small and medium-sized enterprises in adapting these new concepts. This all should build on the strengths of Germany, and we reached out in particular to some countries where we felt collaboration is most important. It was Europe, but it was on the other side in Asia, China, Korea, Japan, and we also worked very closely with the US and recently India. You can see here that at the end, let's say out of this work, 2 subgroups were launched around standardization, the Standardization Council, which is a separate body but in close link to this platform, and on the other side, to support the small and medium-sized enterprises, the Labs Network Industry 4.0, which should help medium-sized enterprises to find the right place for testing Industry 4.0 concepts. If we look more into the details, what is the role of the Standardization Council? Now, first of all, harmonization. I think if you want to move towards the digital economy, you have to first of all have a common understanding, let's say, how digital global value chains should be constructed with all their local specialities. And the second point is that you have to bring all the things in alignment with platform Industry 4.0 and these lab networks. Now, collaboration is cross-domain standards. I have just heard that this conference is also focusing on battery, and I'm also heading the German platform for the future of mobility, and can tell you how important standards cross-domains are, because 10 years ago we started to standardize between the automotive industry and the utilities, which was new at that time. And over the last 3 to 4 years, I think in particular because of the digitization of the automotive industry, standards, let's say also including the IT industry, are becoming important. So cross-domain is key. And in addition, these council is also connecting all relevant standardization organizations in Germany, in Europe, and worldwide. Implementation is key, so we initiate those standards, but also, let's say, pilot some of potential standards, validating them, and if we feel the results are valid, then we try bringing them into the standardization bodies. And last but not least, this council is, let's say, publishing a standardization roadmap, Industry 4.0, and updates are planned for the Hanover Fair during the next years. What about the LNI test beds? It's all about small and medium-sized enterprise enablement, but also about standards, as you can see here. It's, from my point of view, bringing international cooperation really into practice. Now you see to the left side the example where we cooperate with Korea and with the US on validating and testing the asset administration shell, which is the key tool, I would say, to create digital twins. And from my point of view, is the most important topic to agree on standards, as we will see later. Another example where we work with Japan and China is open edge management or time-sensitive networks, the specification for OPC UA, which is now more or less an accepted standards on the shop floor. So if we go to the next slide, we see now that a few years ago, this platform and the steering board of the platform has given itself a new mission for Industry 4.0, a 2030 mission. And the headline is now Shaping Digital Ecosystems Globally. And we work more or less on 3 pillars. The first one is interoperability. It's more or less, let's say, refreshing the idea of interoperability and standards and extending them, as we will see, beyond technology. The second one is sustainability, moving forward, in particular in this direction of circular economy and rethinking how new ways of working will look like, in particular with the advent of artificial intelligence and with the new requirements from the pandemic that we have more distant work to do and to combine, let's say, remote and on-site work in a reasonable way. If I move on, then from my personal point of view, we have a roadmap towards this digital connected economy, which follows 4 steps. And I have seen that Korea is following a similar roadmap, because in particular, the starting point, the digital factory, is key in Korea. And I just want to remind us that the digital twin is what was mentioned before and the speeches is key, as well as the human-machine interface and team robotics. I go into detail to all of these 4 steps. The next one is around the digital business model and let's say smart services. Here it's a question how we can create next generation business processes and building business networks. That is the question then, do companies really have networking capabilities beyond technology, also on a business and legal level? And last but not least, data spaces, which are the key element for building a digital economy. It was mentioned that Korea is one of the first hubs in Gaia X, and Gaia X is a base, I would say, of creating joint data spaces. So in particular here, it's all about let's say international guidelines. Can we agree on guidelines on the technological, legal, and business level? And last but not least, can we agree on a joint governance for all stakeholders? Now, going a little bit deeper, and let us remind us where we are with the digital factory, then you can see here that we have achieved already a lot. I think we have agreed on OPC-UA as the emerging standard. We have created data shadows. We have installed, as we have heard earlier, on a brownfield enough cheap sensor technology in order to extract all the data necessary to get transparency around factories. What's needed is in particular the rollout of 5G, as it was mentioned, building, let's say, a kind of an edge cloud continuum in order to take care of the, let's say, time sensitivity I have just mentioned. Machine-to-machine communication is on a millisecond. We have to continue to work on team robotics beyond just cobots. And as you know, we have to move, let's say, the production from rigid production lines to more flexible production cells. In the center still is, let's say, the digital twin, which is the virtual representation of the reality, and let's say coming to global standards around these representation, which is defined in the concept of the asset administration shell. What about the digital enterprise? We have just seen we have 2 movements. One is, let's say, we go more to high automation, where we replace routine work, both physical work and cognitive work, let's say by machines, using artificial intelligence in particular. This is on the shop floor where we implement edge computing. And on the other side, I think we have still work which is behavioral, where relationship building is important, where creativity is asked for. And that's where we need collaboration, in particular in a business network, because the business model of the future comes from the consumer, and personalized solutions means that at the end of the day, no company can deliver this itself. That's why we are building ecosystems. That's why we complement in a company the missing product, services, and software tools we need in order to fulfill these needs of a consumer by partners, business partners, and forming such an ecosystem which can deliver on the, let's say, on-demand requirements of consumers. And we will, let's say, engage in different levels of the value chain with different networks. In design, these are different people, let's say, if compared to, for example, a logistic network or an asset and services network. So that's, let's say, what will happen in the future, breaking up the traditional business processes and seeing what are more automated tasks where we can hand over to machines and where have we more behavioral work, where we work in teams beyond the boundaries of an enterprise. Now, that brings me to the concept of the digital ecosystem, which, let's say, we have discussed many years ago, where we, let's say, showed that on the left-hand side of the slide, there is a stack we have to provide coming from where we collect the data on the shop floor by, let's say, more implementing sensor technology. And with AI, we can now improve the quality of the data by AI-based data curation. And we can use this intelligence to fuse the data, bringing data together from different sensor techniques. Next is the platform operator. That could also be an exchange operator where we, let's say, have machine learning. And on top then, if we create these smart services, we can implement chatbots in order to have intelligent recommendation systems that help us, let's say, to improve our products and our solution more or less step by step, not in batches year after year, but I would say day by day and work by work. And on top, I think there will be in future more models, not only or digital twins of the assets in a factory, but also digital twins, let's say, models of the consumer in order to create an idea of the intent and the behavior of consumers. A key in this stack is a platform, and it tells you how important data are. We are living in a data economy, and how independent companies, in this case, I have taken an example from SAP, which are trustworthy because they are not, let's say, in these domains, there are no competitors, can help to create such an ecosystem to, let's say, collect all data within a network. For example, if it comes about building, where have you normally a general contractor and subcontractors, that all the data are shared, that they enrich the data, that they do the data fusion, that they do the analytics, that they do the forecasting, etc. So data-based additional value-adding services, which they then can, as a new business, let's say, offer to the members of the ecosystem. Now, having said this, you see again how important standards are. And I come back, let's say, to the creation of a global digital ecosystem where this concept of semantic interoperability is so important. You know, semantic interoperability, we needed already for the digital factory. On the shop floor. But now it's about building ecosystem. So it's a question, let's say, how can we build standardized data models for different aspects of an asset? As I just mentioned, a central element of a global digital ecosystem are these data spaces. And here data are shared in a trustworthy way. And securing the data sovereignty of the individual members is secured, and therefore we need standardized semantic data models for these different aspects. For example, on aspects of sustainability, like energy efficiency or CO2 footprint, or on aspects of circular economy, where it's about remanufacturability, so more design aspects, or if it comes about simulation or the digital nameplate. So that is, to some extent, this extension of the asset administration shell with these data models, the basis for building a sovereign industrial data space based on Gaia-X, where Korea is also working on. And on the lower side of the slide, you see the digital nameplate as a pilot application with the benefits it's giving, like these global access, where all documents are there in all languages, or it's based on international standards, and it's supporting sustainability, and at the end, saving time and cost for the enterprises. Now, With that, we come to the concept of a digital economy, and I have just mentioned data spaces are the key enablers, and they are also the basis for new business models. I have shown here that Gaia X, in the meantime, let's say, has more than 2,000 partnering companies, that more than 100 use cases show the potential and the value proposition. And Gaia X is nothing else than, let's say, a kind of an infrastructure, a framework, an architecture of standards, of policies and rules that, let's say, help build an open infrastructure which supports interoperability, but also portability, so that we can avoid lock-on of consumers, and that consumers can switch from one provider to another provider if they feel their data should be located in different countries because of criticality and because they want, let's say, to have their data within a certain legal regime. And that tells you again how important, if we move to a digital economy, it is to move standardization beyond technology to the level of business, of governance, of rules, of regulation. And you see here that on top of this Gaia X as a kind of infrastructure, we are now starting building data spaces for different applications, for example, for mobility, but also for Industry 4.0. And on top, these use cases are more or less following the concept of smart services that I have mentioned already earlier. Now, the front runner was the data space mobility. That is a big movement now in Germany and will be extended to Europe, where we have, let's say, brought all stakeholders to the table, which wasn't that easy. Now, the platform Industry 4.0 has looked to this approach and decided recently that they want also to build a data space Industry 4.0. They have created a position paper where it was made clear what the benefits are. The benefits are that it's a collaborative network. It's a collaborative network providing the technical, legal, and business foundations for tomorrow's digital ecosystems, but also a platform which companies can use as a common basis for multilateral data exchange and cooperation. Now, you see on the picture that the first use cases picked are well-known ones. It's condition monitoring, it's supply chain traceability, which I think is important in particular. And now with COVID, where we have seen that the resilience of supply chain is a key issue we have to solve. And last not but least, it's also about manufacturing as a service. Having said this, I have now touched the concept of resilience. Some people felt that with resilience becoming so important, in particular of supply chains, that is the reason why we have to move to an Industry 5.0. But that is fundamentally wrong, because if you look back to the first recommendations, you will see that in particular, after the economic crisis, we felt resilience is key. And one of the use cases we highlighted was the resilient factory. So we have recently, let's say, published several papers from Acatech on this topic, and I just want, let's say, to highlight a few points from the automotive industry. I think it fits because you also speak about battery. So first is recommend, yes, we have to increase our adaptability, and that means we have to continue to push Industry 4.0. The second one is, yes, we need a trustworthy use of data. And that is, we have to hurry up to implement data spaces and to build trust where government can act as a mediator. And last but not least, we have seen recently that the shortage of chips is hindering the industry to produce more cars. At least they cannot produce as many cars as they want. It might be not so much an issue for Korea because we have Samsung, but it's a big issue in Europe, and therefore we recommended to strengthen our ecosystem in Europe, let's say to build a big project which should move the European capacity, which is today around 10% up to 20%, which is roughly the consumption Europe has in ships. And last but not least, it's all about batteries for electric vehicles. And here we felt it's key to start first with building a recycling network to establish all the standards necessary to come to, let's say, a full recycling for traction batteries. And that means we have to promote the concept of circular economy, which I show you here. It's simple. The left-hand side tells you that with Industry 4.0, with smart services, with autonomous system, we have already laid, let's say, a basis for entering the circular economy. And on the right-hand side, you see the entire cycle. Let's start with selecting the right raw material, hopefully recycled ones, more sustainable material. In particular important is the question of design. We have to construct products and we have to change our construction principles and design principles in a way that products are made from the beginning, let's say, for reuse of components and remanufacturability. In a production, Industry 4.0 is exactly helping in bringing more efficiency towards energy and resource consumption. And if it comes to usage, it's a concept, smart services, where we move from, let's say, having our own product to, let's say, as a service business models. You know that a normal car is used 2% of its time. And you can imagine what it means in saving resources if we share cars and we bring up the usage, let's say, to at least 20%. And last but not least, it's very important that we implement more collecting things in order to close the cycle. Now, having said this, the question is, can we design strategies which can in parallel help companies to move both to the new world of, let's say, a company which is providing new business models which move from product orientation via usage orientation to result orientation. So to sell, for example, guaranteed quality. That is, let's say, a transformation which takes time and includes a lot of digital implementation. On the other side, if we want to go more to sustainability and high circularity, then we see on the left-hand side, we have, let's say, to come from pure recycling to a design where it's more possible to remanufacture, to reuse, and even to repair. So you see both directions span a matrix of strategic options for enterprises to move in a direction which at the end brings them to both, let's say, to a business model of the digital age and, let's say, to a circular economy where we, let's say, have, let's say, a high level of sustainability and consume less resources and energy than today. So that brings me to the final topic, which is more or less people. I think the social aspect is key. I think if you look to the new way of working, then we have to rethink our business processes. We have to look to the different tasks on the one hand side and to decide where humans are better, where machines are better, or where can humans and machines can complement each other in working in a hybrid mode. For example, humans can train machines and machines can help humans in amplifying things or helping in interaction, etc. On the other side, with the new pandemic, we have seen we have to mix up, let's say, our new model of working and deciding what must be done on site, what can be done remotely, for example, office work, and where we have to switch and have to be flexible in shifting, let's say, between either on-site or remote. Now, having said this, you see that that has an impact also on leadership and culture. And I just want to, let's say, to mention here that this is also a topic where we feel we have to work on. We have to rethink the role of the office. We have to think about how we design a corporate culture, because we have to move now from the traditional way where we have a culture of present to a culture of trust. That is a logical consequence, and might be over time is also something where we have, because many companies are working in a global environment, to come up with a kind of standards and rule, let's say, how we bring leadership in this new environment of working. With that, I want to close, let's say, my speech with just, let's say, coming back and you see here that our mission is reconfirming the need for cementing interoperability, but now bringing from a level of the digital factory to the level of interoperability in open business ecosystem. We all know that sustainability is a key challenge, a global key challenge, and with circular economy, we can address the need for continuous growth, but growth that is decoupled from resource consumption, what exactly I think is important. And we have also seen how we can implement new ways of working in order to provide a benefit to employees in a better and more meaningful work. Last but not least, because of the resilience, because of these issues in the supply chain, the topic of sovereignty, self-determination popped up again. It's about plurality of options, of resilience. It's about having standards which brings the concept of plug and play, which we have implemented, let's say, on a shop floor amongst machines now on a level of business partners. If you have several business partners who can fulfill the same needs and you can switch amongst them in an easy way, then you have really built an adaptive ecosystem. So that means all of these I think, show us how important international collaboration is in all aspects, in particular of standardization. And we know there is a long history, a good history of collaboration between Germany and Korea. Last year in December, I remember there was a meeting between the minister, your Korean minister of SME, and our German minister for economics, and they reconfirmed, let's say, the cooperation and continued the cooperation. And a particular point was on standards around the Lab Networks initiative supporting SMEs of both countries. So I thank for the invitation to this conference and hope it will help all of us to continue and to strengthen this collaboration, in particular on the level of standards. Thank you very much.
Thank you very much for the keynote speech. We're now going to have a Q&A. If you have any questions, please raise your hand. We will deliver a microphone to you. Yes, we see a hand. While I was listening to your presentation, I recognized the importance of collaboration once again. Yes, please go ahead. Hello? Hello? I am Park Jung-han from VD Korea.
First of all, thank you for your valuable presentation. As we know, due to the circular economy is a... Can you hear me? Hello? Can you hear me?
I have difficulty to understand you. It's from a level of might be the interpreter can say it in English so that I can understand. Yeah.
통역사가 영어로 해주시는 방법도 있습니다.
Thank you for your valuable presentation.
It's too loud.
네, 그러면 지금 약간 지금
I think it would be better being, having the interpreter communicate the question. So first of all, thank you very much for the valuable presentation.
최근에
Recently,
기후변화,
climate change or climate crisis, as well as a focus on ESG management and resource recycling, all of these factors are putting a lot of focus on the need to promote a circular economy around the world. Now, from the point of design,
이제 이런 그 순환 경제가 그러니까
if such
반영이 되면 비용이
circular economy is to be promoted, I think that's going to create more cost burden for the companies.
이런
So how can we
재활용을
promote a balanced development between resource recycling and circular economy to ensure sustainable and mutual growth for all of the companies in the industry? Do you have any advice for that?
Yeah, thanks for the question. I am not sure if, let's say, moving towards a circular economy concept will be at the end more expensive for companies. You are right. I think changing the way people are designing their products will take time. It's a question of culture and transformation. But at the end, I think the benefits are huge. And in particular, let's say we have no chance from a, I would say, from a global perspective, because you will not achieve the goals of, let's say, CO2 reduction, others without applying circular economy concepts. It's all about taking waste out of the system. And if you look into the studies, and there are three areas where we can achieve most. One is housing, by the way, very difficult. The second is mobility, and the third is agriculture. It's food. It's 50% of what we have to achieve. And coming back in Germany, I have to say, in mobility, it's common sense that we will go there, and therefore I have mentioned this battery. I think the first pilot where we have collected, I think, or bundled all the forces we have, it's about building, I would say, the circular economy concepts for traction battery life cycle. And now we will see in the next years if it's really a burden for companies, but I don't think so, because on the other side, we don't have enough raw material. And I think to come to a level of 80–90% of recycling of the batteries is absolutely necessary.
네, 여기까지 이렇게 답을
So
들었습니다.
thank you for your response.
지금까지 우리 기조 연설 해주신
So
전 원장님께
our two
다시 한번
keynote
큰 박수
speakers
부탁드리겠습니다.
and also Dr. Kagaman, thank you very much. In the interest of time, we can only take one question. So thank you once again. So we have just finished our opening ceremony and keynote presentations from Korea and Germany for technology standardization. Before we move on to technical presentations, we'll take a 10-minute break. We will see you again at 3:35. Thank you.
Thank you.
네, 모두 자리에 앉아 주시기 바라겠습니다. 잠시 후
Ladies and
테크 이슈
gentlemen,
발표
please take your
시작하도록
seats so that we
하겠습니다.
can begin the technical issues session. Thank you.
네, 브레이크 타임 잘 즐기셨습니까?
I hope you enjoyed your
한국과
break
독일의
time.
국가 표준 정책과 양국 기업의 표준 전략을
Today we are
공유하고
talking
또 한국
about
양국의 표준화
the
협력
technology
방안을
standardization activities
표준
and
컨퍼런스.
efforts between our
이제
two countries.
마지막 순서만을
And now we are
남겨두고
at the
있습니다.
last session
4차
of today's
산업혁명의 강국인
conference.
독일의 주요 기업들의 분야별 테크 이슈 발표가
A fourth
있는데요.
industrial revolution
먼저
powerhouse
첫 번째
Germany and a
순서로
digital manufacturing
지멘스의
powerhouse
랄프
Korea. We
스프로
will now
표준화
hear technical issues
이사님께서
presentations from experts from the two
준비하고
countries.
계십니다.
The
네,
first speaker is Jeong-yun Choi from the
국제전기기술위원회
Korean
ICA 표준화
Certification
관련
Laboratory, who will be
의장이시기도
speaking
하는데요.
about
네,
safety
기업 관점의
standardization
스마트
of
미래와 표준의 역할이라는
batteries.
주제로 발표를 진행해 주시겠습니다. 발표는 화상으로 진행되는데요.
The presentation will be
만나보도록 하겠습니다.
made via video.
So can you hear me well?
Yes, please go ahead.
So actually, I'm sorry that I have caused here a slight glitch in the agenda, and I apologize to the conference organizers and the other speakers, but I've asked to have my presentation right after Mr. Kagaman here because I have some obligations to be in other meetings right after this presentation. So sorry for this. My name is Ralf Sporer. I'm with the company Siemens, and I'm there engaged with standardization activities. I also am very active on the IEC level. In IEC, I'm the chair of the Standardization Management Board, which is governing the whole technical work of IEC, and I'm co-convener of a strategic group there which works on digital transformation and system aspects. And that's the topic I wanted to talk about today, really why the company Siemens is actually engaged in these activities, and how does standardization fit into this smart future, this new world that we are seeing emerging now. And Professor Kagaman, the previous speaker, has excellently shown the challenges of what's coming to our attention and what we need to deal with as a company. And I will show slides which on one hand complement what Professor Kagaman has shown from our viewpoint as a company. Of course, Industry 4.0 will be again a very important part of that, but this goes obviously also beyond that in other areas. And then I will also connect to Professor Kagaman's view on how we are building this data ecosystems by explaining how we as a company think it's necessary that standardization becomes an integral part of those digital data ecosystems. So with that, let me show the first slide is just explaining a little bit where I come from and where the company is working on, and I'm sure you know Siemens in the one or other form. Siemens is a company based in Germany, which has a global footprint, of course, and we've been around for more than 150 years, working in different areas around electrification. So we haven't been around for the Industry 0.1, the introduction of the steam machine, but after that, everything after the introduction of electricity is connected with Siemens, and we've been active in many of those fields. And today, Siemens is kind of a collection of different companies ranging from the healthcare area, where we are looking into personalized healthcare, into affordable healthcare, and developing solutions there, to the energy side, where the big topic obviously is decarbonization and distributed energy systems. But today, still the core of Siemens is around industry, general infrastructure and mobility. And the challenges that we see here are actually challenges that have been already named by Professor Kagermann. It's about digitalization, it's about globalization, value chains. It's the trend, increasing trend on urbanization. Like 70% of all the people living on the world are in cities. It's the big challenge of climate change and the necessary consequences that we as societies have to take, like the decarbonization, like the circular economy. In many of the developed countries, is also around the democratic changes. Our society here in Germany is getting older. The share of older people is increasing, and that's nearly true for nearly all of the developed countries, and we have to tackle these changes with specific solutions and services. And the latest here on the lower part of this picture is really, as already has been mentioned by Professor Kagermann, it's this kind of flexible working and physical distances which was put on us by the pandemic, and which has profoundly changed really the way that we work and the way that we interact as societies. So starting from these challenges, the questions obviously from a company viewpoint is, how does that change the expectations of our customers? And for the pillars of the areas where we work, it means that customers are really expecting an energy supply which is reliant, which is up 100% of the time or 99.9% of the time. On the other hand, it gets much more important that this is a sustainable way to provide an energy supply which is not built on fossil fuels, but which includes a massive share of renewable energy and makes that also available in an efficient way, because for many of the people, it's a question of money, whether they can afford access to an affordable energy. For industry, we heard a lot in the previous talk around what this means. We're going down to individual products. We are going to change our business model towards not offering products, but offering services, and even offering integrated value generation with our customers. Certainly, digitalization also allows us to really optimize not only the production, but all parts of the life cycle, including design, including usage, including maintenance and stuff. And I already touched on the point of flexibility, that such plants will be much more flexible in producing specific products and services. And finally, around the building sector, or even I could call it the cities area, it is really about providing services which are centered on the needs of humans, and where the building kind of offers those services that really are important to those people who are living in those buildings. It also needs, of course, to be very energy efficient and sustainable. And we are not talking about zero emission buildings only. We are also talking about buildings as being part of the producing energy for the general good. So all of that is really kind of driving our company. And what that means is, again, and this is picking up on something that Mr. Kagermann already explained, it's about really building ecosystems across different formerly isolated domains like energy supply, buildings, and even industry. And how does that look like for Siemens? For a long time, we've been looking at that as an energy supply side and an energy demand side. And they were separate, and there were separate companies offering specific services on the two sides, so to speak. Those that supply the energy were the utilities, people who were looking into power generation, transmission, distribution, Usually at the interface, we had a smart meter, or we had a meter, even if it wasn't smart. And on the energy demand side, we had the buildings, the industry, the mobility, the healthcare activities. Now, this is increasingly merging, and we really talk about that as the grid edge. And this is a little bit different to what we've seen previously in the industry, where you were talking about edge at the connection point between the devices. The grid edge is really connecting specific ecosystems already. So in our viewpoint, this is really something which is at the core in providing services for different players. And again, these players are no longer just looking at products. They are looking at ecosystems where customers and producers and manufacturers come together and provide specific services in their domain, whether this is industry, whether it's a campus, whether it's large commercials, whether it's local energy communities, or on the supply side, whether it's the utility, the distribution system operator, or even service providers, energy service provider. And they all come together in this area, which we call the grid edge, where we bring together the services and the solutions in a digital form that connect all those different parts of the overall picture. And they offer different kind of solutions like microgrid, like virtual power plant, like building performance and sustainability. So over the last years, we've seen an evolution in our sector. When I look at the energy and the building sector, where we came from about power generation in the last century, I should say, and building controls towards more automated buildings and more automated energy systems, which were still focused around questions like how can I manage the building, how can I integrate large bulks of renewables, and how can I transport it in an efficient way from where it is produced to where it is needed. And today we are at a level where we're talking about smart buildings, about smart grids, and really we have also changed not only the solutions, we also have changed the roles in this kind of ecosystems from consumers and producers towards what we today call prosumers. And I already talked about this issue that cars, electric vehicles become a source of production, that smart buildings become a source of energy production, and so on and so forth. And they all have to work together. And the main point here is really that the data that you need in order to connect all the dots gets much more, and it gets much more important. From here to the future, we see an increased activity also around certainly applying artificial intelligence on managing digital grids and smart buildings, which will give us again a lever to increase even the offerings that we have today. Now, this is a little bit the ecosystem in which we are, and let me now come back to a little bit nitty-gritty details. And we have already seen with Professor Kagermann that, for example, the role, how do we actually structure those offerings? And this is really always a little bit the same thing. We have to onboard OT devices in a specific way. We put that together in a kind of a data lake, which we are putting on an IoT platform. And then on top of that, we are really offering solutions which span across domains and which are not only concentrated on industry, on buildings, on energy supply, but which can really provide solutions which span all those different domains. Now, how do we do that in more detail? Again, here the Industry 4.0 concept of the component with an asset administration shell comes in. And here the trick really is that the administration shell is kind of an interface that describes the necessary data and information on the specific asset and transports it and makes it available to all the usage by smart services on the top level. And again, this is not only looking at specific products, which is today the state of the art. We can describe assets when it comes to their mechanical and electrical capabilities. We are also able to describe what are the functionalities and the capabilities of those specific assets. Increasingly, however, and this is building on the concept of circular economy, we also have to include models that describe other than the original product properties. Again, I can connect to my previous speaker who has said that we need to really tackle different aspects with this kind of concept. And currently there's a huge push towards really integrating the sustainability issues like the greenhouse gas emissions and the carbon footprint into a specific submodel so that we can deal with it and keep it under control and offer specific services. However, this is not so easy. And if you look at that picture, this is a German initiative of the ZBEI, of the German Association for Electrical Engineers, which tries to really put together the carbon footprint of a control cabinet. Now, there are multiple questions and multiple opportunities for standards here. If you look at the right side, what you can see here, as a typical manufacturer of a control cabinet, the direct emissions that you are producing are only representing less than 10% of the overall emissions of the control cabinet. And the reason, not very surprisingly, is the supply chain. In the supply chain of your supply of the supply industry that actually puts some pre-manufactured parts of the control cabinet and provides them to us as a final manufacturer, this really already takes a huge amount of the greenhouse gas emissions and of your carbon footprint. But also the usage of your product will play an equivalent important role. And it's really important to understand how the product is used to come up with an overall estimation of your carbon footprint. All of that, of course, needs to be comparable, and we need standards in order to really understand how this all comes together to the carbon footprint that is accepted worldwide. So that's a really difficult question, and there are still a lot of things that we need to do on the side of the standards. Now, let me come to the last part of my presentation here, in which I'm going to assume that standards also have to change. Because my assumption is that in such a submodel, also standards are represented in a digital form so that we can reuse the information contained in a standard directly in the overall ecosystem that we are building up to better understand and serve our needs. So what do standards need to do? And we already touched on in a future world, in this context of domains that are coming together under circular economy aspects, under Industry 4.0 aspects, and so on and so forth. Well, we already heard, obviously, that we need standards as a base for semantic interoperability. They provide the means for the exchange of data, and that's clear that that's an important role that standards have to provide. They represent information in a structured form, which means that we can readily reuse them in a digital format. And of course, as also Professor Kagermann has said, standards are also a way to really support and provide harmonized approaches on the international level. And as he has shown, standards also need to touch into new areas like governance, like legal frameworks, like sustainability, and there are specific needs for us to tackle these challenges in future. From my viewpoint and from the last slide that I showed, we are committed to that, thinking that standards need to become available in machine-readable format that can be exchanged with other repositories, whether they are Industry 4.0, whether they are coming from the building sector, like the building information model, and so forth, or in repositories that describe the sustainability aspects. So we also think that they need to be accessible from any device, even if this device is a machine, and that they must be more flexible in the use and development. Now, in my last slides, I'm going to show you the activities in which Siemens is active, and they come back certainly to the national level on Germany, but also on the international level. The first I'm going to show is an initiative of DKE and DIN, who have put together the Initiative on Digital Standards. This is really looking into defining, and this was started last year. It's trying to define digital standards for the future. What does it mean? What kind of use cases do we have? And you can see here the structure of this activity. They have 3 working groups, one on the vision and roadmap, which is mainly about understanding what a machine-readable standard is, what is a digital standard. We have a block on use cases where we are collecting, but also exploring specific use cases and putting them to pilots where we are testing our concepts. And then we have a working group 3, which is really looking into international activities. A little bit more detail here on this slide, you can see the work of the working group 1. You see the so-called utility model that has been developed actually in conjunction or together with IEC and Senelec. This shows the evolution from a digital document to a machine-readable document, which is called level 2, a machine-readable and executable content, and finally a machine-interpretable content. And this is the real international model. It goes up to level 4. Level 5 is really the application of AI, artificial intelligence, to standardization itself, which is really a future topic, which is not at the center of the focus of our work in Germany. And we put together a white paper on scenarios for the specific levels, and you can see a little bit the details here. We are thinking about standardization along the whole life cycle of standards, from content creation to content usage. And what does a level 3, a level 4 environment mean for such a production of standards and also the usage of standards? This German initiative is kind of complemented by the international activities on the IEC side. In IEC, there is a strategic group 12, which deals with digital transformation and systems approach. You can see the structure of these activities there. We have 3 task forces. The first one is really looking into how we can work more digitally. And here we are running a pilot on online authoring for IEC standards, where we are trying to really move to more collaborative ways of producing standards. The task force 2 is looking more into what kind of digital content are we going to produce in the end. And a big part of this task force 2 activities is really collecting potential future use cases, how we will use standards once they are available in a machine-readable and executable format. And the third one, task force, is really on semantic interoperability and information models. And it has 2 main work streams. The first one is really to look into what kind of ontology, what kind of semantic do I need in order to exchange information between different domains. So this is very much looking into sector coupling and trying to really understand how can we produce guidelines and standards that enable such a information exchange across domains. But the second part is even, I would even say is more important, because there we are really producing an information model for standards themselves. We are building a standard information model, which then can in turn be used to directly connect with other repositories and the Industry 4.0 world, the building world, the mobility world, and we will be able to really plug in standards information into this new world of business ecosystems. Well, just one short description of what we are doing there. We have brought up something that we call the IEC Smart Standards concept. And this is really remodeling the IEC standards of the future. We think the first step is that we are cutting standards into smaller fragments, which we call information units. This is available today because we have converted all the standards in XML, and we can, in principle, cut them into pieces. The problem you have when you cut standards into pieces of information is that you lose the relation and the context. Nevertheless, we think with the help of the standard information model, we can rebuild those relations between the individual sentences, tables, and pictures of standards by reusing the fact that standards are very structured information which are governed by the directives. We will have to do an additional step in assigning a capability or a function to an individual information unit, describing what this specific part of the standard actually provides to the end user. And then we need some infrastructure services, basically building up an asset administration shell infrastructure around standards in order to provide standards via APIs on a platform. So that's in a nutshell and very fast the current part that we are dealing with in the IEC when it comes to digital transformation, and how we think that standards need to be rebuilt in order to fit into this new world, which is really around those digital ecosystems, business ecosystems, connecting different domains. And I really believe that also standards need to be an integral part of that world. So to summarize, this is just giving the status where we are today, and I'm not going to explain all of it. We are currently still in working up a work plan here. A very central point is how to get from use cases to real implementation. And this already needs some changes also in the setup of our group and the setup of IEC and how we do the standard development process. And currently, we have already collected a number of use cases, but we think this list is not complete. We need to check it also with others. We need to bring this list to the attention of our members of the national committees in Korea, in other parts of the world, in Japan, in China, in US, and so on. And we need to together expand that list as being the base for future developments and for digitally transforming the standards so that they can really become part of these digital ecosystems, as was shown, as we have seen in my presentation, hopefully, but also we've seen with the previous speakers. And with that, I would like to thank you very much for the opportunity to speak at this important event. And I thank you for your attention and looking forward to any questions. Thank you.
Yes, thank you very much for the presentation. He talked about the Siemens approach and IEC cases, as well as the types of information that we would use to adapt standards to a digital world.
Next, we will move to listen to Mr. Choi Jung-hyun, who is the center head of the Korean Certification Laboratory, who will talk about the safety standardization of batteries, ESS. He's the only person that will be speaking at the podium out of the technical presenters. Please welcome him with a big round of applause.
really appreciate giving me a chance to talk about at this conference. I'm going to talk about the energy storage system fire safety evaluation and standardization up to installation level. As a start, I might just show you a newspaper article, which was quite recent, published in the August 3rd in Financial Times. Actually, the article did mention about the fire cases in the energy storage system in Australia. But in the middle of the article, there was a mention about the description about the fires of energy storage systems. One lead officer of National Fire Chiefs Council in the UK, he did mention, basically what he was saying was, energy storage system fires takes much longer time. And also, when it's, the fires keep coming back, basically after suppression action, and when the firefighters thought they extinguished the fire keep coming back, which is quite a unique thing, and people didn't really come across often, and which has been a quite issue as well. Okay, before going into too much about the fire science, I might just quickly describe about what's ESS. Probably quite often people heard about the energy storage systems and the usefulness and the benefits of them. Basically what energy storage system is, it's a lots of lithium-ion batteries connected together, which is controlled by battery management system, which is controlled by the power control system, and eventually power management system controls all the parts. Why it's so good and why it's spreading? From the house level to the community level up to the grid installation level, it's controlling the power balance. Also, it's controlling the voltage regulation. So if you think about the renewable energies, it can be stored and it can be released when it's needed. So lots of benefits do exist. Again, in the market, it has been increasing quite rapidly worldwide. And if you have a look at the top couple of pictures, in the case of your mobile, it often just contains one cell of lithium-ion battery. And if you move into the laptop, it quite often just contains 6 cells of batteries. And when we are moving into electric vehicle, it does contain about 300 cells. And if we think about grid level electricity, where energy storage system, it does contain more than 10,000 cells when it has about 2 megawatt hour capacity. Okay, energy storage system market, especially about the Asia Pacific wise. South Korea, we do have currently about 8.6 gigawatt hour capacity installed by 2020. And we have a target of increasing 42% of each application in 10 years' time. And we also have incentives, mainly the REC is one of the biggest incentives, and also peak saving special tariff plan does exist. Also in China, they do have a huge application of ESS systems already. They have over 33 gigawatt hour capacity in 2021. And within 10 years' time, they are expecting about 3 times of the capacity. Also, the government and the province level incentives do exist to drive expansion. Comparing with 2 distinctive countries in Pacific Asia, Australia has a bit of a different approach. They currently have about 2.7 gigawatt hour of application, and in about 10 years' time, they are expecting about double times of its capacity. But in terms of incentive-wise, they are more focused about the medium and individual level. It's spreading quite a lot, but intrinsically, lithium-ion batteries do have a potential hazard, which is fire. So it doesn't just happen in the energy storage systems, as you can see, from the submarines to airplanes, electric vehicles, and the grid level connections tend to cause fires. And this year's statistics say the worldwide there has been about 38 major energy storage system fire cases. In Korea, for the last 3 years' time, including small individual cases, we had over 28 cases of energy storage system fire accidents. Most of the cases did cause fires, but there is another case happening in USA, which was in Arizona APS Power Service case. There was a thermal runaway. Basically, it's an irreversible catalytic event of a lithium-ion battery. Then the flammable gases generated gradually more and more. Basically, the self-propagation of the thermal runaway happened. But they did have a quite good system of gas detection, and also they had a quite nice fire suppressing agent called the Novak. When the accident happened, the flammable gas is released, and then the suppressing agent quickly released as well. But when time passed by, the flammable gases accumulated within the compartment, and when the fire service opened the door, the oxygen being introduced into the compartment, and there was an explosion happened. Lots of different cases happened, and how can you approach about that? So basically, there was in the aspect of standard, we had to look back about the current standards. Are they really safe enough? Is there any aspect of revising? And do we need another kind of standard to maximize safety? As a part of the action, Ministry of Trade, Industry and Economy issued a research project, which was through Korea Agency for Technology and Standards, which started in August 2020 with a time span of 26 months. And KShare, where I'm working for, with KTC and the couple of associations and research universities participated in the project. Basically, the mission was we set up the testing infrastructure, and we revised the current standards, and we evaluated the standards, and also we want to provide about the kind of facility for the post-accident investigation. So when we reviewed about the current standards, the standards can be divided into two sections. One is prevention, one is mitigation. As I previously mentioned, when the lithium-ion batteries go into the accident, I would say, the key position is thermal runaway, which is irreversible condition. So basically, in the area of prevention, standards tend to deal with not to approach to the thermal runaway level. And whatever reasons, when the energy storage system or lithium-ion battery goes through thermal runaway stage, we have to go through mitigation. Basically, what it means is we try to minimize damage to the structure and humans. So standards there, and there is a compulsory certification plan do exist. These are some of the most representative standards worldwide. But I would like to say there are some more detailed standards associated. So basically, if you think about the whole scale, energy storage system components and the energy storage system and the installation level and the large scale of fire test required connection with the installation level. So in terms of component-wise, European countries and South Korea are dealing with the IEC standard. And then up until the energy storage system-wise, in the North America, some of the most representative standards are coming from the UL. So basically they are following UL 1973 and UL 9540. And then when it's going into up until the bigger one, the installation level, they are following the International Fire Code and the National Fire Protection Agency standard. Actually, the IEC code 62933-5-2 actually do require installation level fire test as well when it's needed. So my talk going on. So how do we deal with the whole process? On the column left-hand side are the conventional testing schemes. Depends on what type of the abuse you apply for and what kind of test result what you can get. But in terms of if we narrow down the thermal characteristic testing, there are actually lots of testing standards do exist. National level, international level, and some of the technical levels. So if we break down into the every single systems and every single material, we can apply the test. And in KCL, we are dealing most of the experiments. And actually what you can focus on is the bottom right-hand side, large-scale calorimeter. We currently running up until about the 10 megawatt size fire testing. And if I just go back to a bit of lithium-ion battery fires, one of the tests what we performed for the last year was basically what we did was we put the fully charged lithium-ion battery and connected with the heating pad outside, but we thermally insulated. So after thermal runaway, whatever happens, the energy is contained in there. So we can actually measure the whole energy being released and what kind of danger is in there. So by heating the lithium-ion battery, in about 7 minutes time, the thermal runaway happens. And as you can see, the toxic flammable gas is being released. And very quickly, within about 14 second time, it ignites. But surprisingly, the fire doesn't last too much. It only takes about a minute. Then it self-extinguishes. Basically, it just ran out of flammable gases. But the actual right-hand side, actually it's a contour plot of temperature as a function of time. So what you can see is, as a single cell, when it does ignite after passing through thermal runaway, temperature increases, but it's not really kind of balanced because it's happening so quickly. Some other bigger scale experiments, what we did. One is electric vehicle battery pack. It does contain roughly about the over 53 kilowatt hour capacity. So basically, I previously mentioned lots of battery cells inside. And also, when the battery pack is connected to make a whole electric vehicle, what kind of higher dangers, heat release, gas release, and any extra mechanical abuses happens were investigated. And again, the energy storage system REP was performed on the fire test. And the suppression agents, what kind of suppression agent can quickly and effectively suppress fire? These kind of things, experiments have been performed for the last couple of years in KCL. And as a part of the project, what we were participated for from the last year, we are under construction of the new fire testing facility, which is in the Samcheok city in Gangwon province. So basically what it can perform is it can provide much larger scale experiments safely with precise data collection from the heat release aspect, gas release aspect, and safety concerns. The construction of the building or the complex can be divided into 4 sections in terms of actual experimental safety as well. So during the experiment, we have to concern about the safety of the experimentalist as well. So the biggest part, following the color coding, as you can see, the pink part can be more regarded as a dangerous part during the experiment as well. And the danger goes down from yellow, or orange, yellow, and blue section. And actually the last part, the yellow part, is the electricity part. So one of the main issues about energy storage systems fire, people mention about it might have caused by the electricity abuse. So we have a facility to regenerate it as well. And some of the details I might quickly pass through. So it's a kind of design concept. When you perform the fire test, it does cost quite a lot in terms of money and time. So is there any way we can reduce the time and cost? These are kind of things what we are under study. And other thing is revising current standard. There are some issues about the current standard, how we can hit it, and what kind of gases can be tested and evaluated. And another thing is a kind of explosion case we had to deal with. The thing what I want to say last is there are quite a lot of current standards in South Korea and worldwide. Every single bit of standard can't cover all, but they do compensate. And we are in the middle of revising and trying to harmonize it. And these are kind of strategies what we are planning for. I'm sorry about not describing much because of due to the shortage of time. I hope you have my handouts in your brochure. Please do consult. Thank you.
네, 발표 감사합니다.
Thank you for the presentation that was related to the need for standardization in ensuring the safety of ESS and batteries. So thank you very much.
네, 이어서 한국산업기술진흥원
Next,
한국기술협력센터의
we will hear from Mr. Jong-gyuk Kim, Director of the Korea-Germany Technology Cooperation Center in Kyiet. He will be talking about Korean-German cooperation in materials, parts, and equipment industries. He will be joining us online.
네, 안녕하세요. 발표 시작
Hello, can you
부탁드리겠습니다.
begin your presentation, please?
네, 지금 현재 오디오
Seems that
음소거
you're
해제해 주시는
muted.
부탁드립니다.
Can you please unmute yourself?
예, 안녕하십니까. 한독기술협력센터의 김종길입니다.
Hello, I am Kim
이렇게
Jong-gil
온라인으로라도
from
컨퍼런스에
Korea-Germany
참여할 수 있게
Technology
되어서
Cooperation Center.
매우
I'm very
기쁘게
pleased to be able to take
제
take
발표를
part in the
시작하도록
conference, albeit
하겠습니다.
virtually. Let me begin my presentation.
오늘 제가 말씀드릴 순서는 보시는 바와
So this is
같습니다.
the order of my
저희 한독
presentation.
기술협력센터가 아직 널리
As our
알려지지
Korea
않아서 저희
Germany
센터를
Technology
소개해드리고
Cooperation Center is not
한국과
well
독일
known to the
기업
public.
간의
I'd like to
기술협력을
first give you an
지원하는
overview
저희
of our
활동에 대해서
organization and also our
말씀드리는
activities for
내용으로
supporting
발표하도록 하겠습니다.
our companies in Germany.
한독 기술협력센터가 처음
So when the
기획될
plan
때부터
for
가장
establishing
중요한
Korea-Germany
질문이 바로
Technology
이것이었다고
Cooperation Center was
생각하는데요.
first
왜
proposed,
독일인가?
I guess the most important question out there was why Germany? Our center aims to promote technology advancement in the areas of materials, parts, and equipment based on understanding that global cooperation is needed in this regard. As you may well know, Korean materials, parts, and equipment industries rely on neighboring countries such as Japan and China as their partners. Hence, diversification of sources is in order. And as a potential partner, Germany stands out as in automotive machinery, chemical, and other materials and parts. It boasts global technological competitiveness equipped with strong research infrastructures. For application technologies, there are 72 Fraunhofer institutes, and for basic technologies, there are about some 80 Max Planck institutes, and for mega science fields, there's Helmholtz, among other research instructors. And as for Korea, we have a strong IT technology with advanced process technologies and digitalization. And Korea's outstanding middle market enterprises with such technology and Germany's research institutes, universities, and companies are well vetted for each other as partners for technology cooperation. Such partnership could generate mutually complementary global competitiveness. Hence, the establishment of the center was carried out. Our center is located in a part of Germany known for having the largest number of companies and business activities, Nordrhein-Westfalen. With Düsseldorf as its capital, the federal state of NRW is most populated in the country with the highest contribution to GDP. Out of top 50 companies in the country, 20 of them are based here in the NRW, with many global companies having their presence here, also including RWTH Aachen University. 70 prestigious universities and many research institutes are situated, thus offering a large pool of R&D manpower. Therefore, for Korean companies to seek their partners for tech cooperation and conduct their development, NRW offers the most conducive environment. The picture here shows the NRW, and in particular the Aachen region, where our center is located, sits on the west tip of Germany, yet is at the center of Europe from a wider European perspective. This makes it suitable to pursue cooperation with local companies in Germany, as well as those in the Benelux 3, France, and UK in terms of communication. Such advantage in location played a crucial factor in helping us decide where to go. In the materials, parts, and equipment sectors, to support the efforts to improve their global competitiveness, the need for partnering with Germany became well recognized, and since then, the establishment of the center gathered momentum in our two countries. Korea's MOTI worked with Germany's Federal Ministry for Economic Affairs and Energy to agree on strategic cooperation in materials and parts, technology development, and commercialization. And with the NRW state government, agreed to establish our cooperation center. And under this agreement, Korea's KIST and Germany's NRW Global Business worked side by side as practical partners for its establishment and operation and came to open the center in Aachen. The slide here shows the facade of the Technopark where our center is located. We call this Technology Park TPH in short. There are some 80 tenant companies employing 2,500 people. In the Aachen region, many startups are set up in this park and grown into successful businesses, thereby helping the Aachen and NRW maintain their economic growth. As we worked on establishing the Korea-Germany Technology Cooperation Center, we identified Korean tenant companies who wished to enter German and a broader European market. At the moment, there are 10 such businesses focused on acquiring new technologies, developing new products, improving existing products, pursuing joint research, among other various activities, with German's industry, academia, research institutes. Next, support programs for tenant companies. They are broken down into 6 main programs. Let me just go over them briefly.
입주 기업의 협력 파트너가
to
될수
find
있는
cooperation
우수
partners for the tenant
기업들처럼
businesses.
이렇게 히든 챔피언이라고 하는 우수
Like the
기업들을
hidden champions, we help find these hidden champions,
기술 경쟁력 강화를
and we match them
지원하고
with the
있습니다.
tenants
이를
to
위해서
support their
입주 기업의 활동을
technological
독일 내에
competitiveness.
홍보해서
And we
독일 우수
also
기업의
promote
관심도
activities of the
유도하고
tenant companies to induce the interest of
또한
outstanding local
독일의
firms.
유수한 대학과 연구기관
And also
등
renowned
기술 개발
universities,
주체와
research
네트워킹을
centers, and
지원하고
other
있습니다.
technology
이
development
네트워킹을
entities in
통해서
Germany are
입주 기업의
contacted
협력
for
파트너를
networking
발굴하고
opportunities.
공동 연구 등
And such
기술 개발
enables us to
활동을
locate
계획할 수
suitable
있게
partners for the
지원합니다.
tenants and pursue joint research and other
그리고 독일 및
technology
유럽의
development
진출에
initiatives.
도움이 되는 정보를
Moreover,
제공하고
information
우수
for
인력을
market
발굴할 수
entry in
있는
Germany
기회를
and
제공하고
Europe is
있습니다.
provided,
특히
along with
독일에서
opportunities for
활동하고 있는
identifying excellent
한인공학자나
manpower.
공대
Korean
유학생들처럼
engineers and engineering students in
한국인으로서
Germany are
독일에서
brought into the
활동하고
network
있고
to seek
현재
advice on the
수업하고 있는
technology
분들과
development or
관계
induce their
구축을 통해서 기술 개발을
participation in
자문한다거나
projects.
프로젝트를 참여할 수 있게
A
한다거나
relevant foundation for
다양한
such
활동이
diverse
이루어질 수
activities
있도록
is created
기반을
to
조성하고
support
있습니다.
these tenant companies.
저희 한독기술협력센터의 소개에 대해서는 이 정도로
I've so far
가름하고요.
briefed you on
이제
Korea-Germany
참여하고 계신
Technology
이
Cooperation Center.
컨퍼런스 듣고 계신
In my
분들께
final
좀
part of the
도움과
presentation, I would
협력을
like to
요청하는
ask
분들께
the
잠깐
participants for
간단히
their
드리겠습니다.
support and cooperation for the following.
저도 그렇지만 한국 사람들이 커피를 매우 많이 좋아한다고 합니다. 그래서
I'm a coffee lover just like
커피를
any other
여기
Koreans.
지금 아엔에서도 제가
And I like having coffee here
커피를
in
사
Aachen,
마시러
Germany as well.
나가는데
I usually buy coffee, I
어느
go out to
유럽 어느
drink
나라를
coffee.
가더라도
But in any
자기네
part of
나라만의
Europe you go,
자신감과 어떤 자부심이 있는 유럽 사람들이 커피 주문을
the
이탈리아어로
Europeans,
하는
such
게
proud
좀
people, they would always
재밌다고
order
생각을
coffee using the Italian name
어느
coffee.
나라를 가더라도
I thought it was quite
우유 탄
interesting.
커피는
So
카푸치노나 카페
it's either cappuccino
라떼
or cafe
마키아토라고
latte
하고
or latte macchiato if you
에스프레소를
put
넣은
milk.
커피는
And if you put
이탈리아어로 에스프레소
espresso,
도피오라고 하는 게 좀
it's called
재밌다고
espresso
생각이
doppio as
되었는데
stated in Italian,
이게
and that's
왜
how you would order your
그런지
coffee.
좀 찾아봤더니
And I wanted to
약
understand the origin of
100여 년
this.
전에
It is that
이탈리아의
about 100
과학자나
years ago, the
엔지니어들이
Italian
처음으로 커피를
engineers
추출하는 기계를
made
만들었고
the
그때부터
coffee extraction machine,
이 기계를 통해서 추출된
and any
에스프레소를
coffee
만든
or any espresso-based
이름들이
coffee extracted
이탈리아어로
using this
붙어졌고
method
더
would be
나아가서는
given an
커피의
Italian
공식
name.
용어가
And furthermore,
이탈리아어로
many
됐다는
official coffee-related terminologies came to be called in
우리가
Italian as a result.
학문적으로나 어떤 정책적으로 개념적으로
Academically,
말하는 표준과는 조금
or
다른
from a policy point of
수
view.
있겠지만 우리 기업들이
Well, this
생각하는
may be a bit different,
목표나
but I think the
표준이라는 게
goals or the
이것과 다르진
targets that
않다고
many companies
생각을
do
합니다.
have in mind would be quite similar
저희 한독기술협력센터
in this
입주한
regard.
기업들도
So
또
many
많은
tenant
기업들도
firms in the center, as well as
남들보다
other
먼저 기술을
companies,
습득하고
would
개발해서
envision
그
to
기술이
have
업계의
such
기준으로
leadership
자리
and
잡는
standards,
것을
being ahead of the curve in obtaining technology and establishing that technology as an
그런
industry standard are the common
그런
goals that we
목적을
all
이루기 위해서
pursue.
독일과의
And to
기술협력이
achieve this
독일과의
goal,
기술협력을 저희도
technology
지원하고
cooperation is an area
생각합니다.
where we're providing a lot of support for.
저희 한독기술협력센터 기업은
The tenant
자동차
companies in the
부품,
center are working in the
기계,
areas of auto
바이오,
parts,
전기전자
machinery,
분야의 파트너를
BT,
찾고 신기술을
and
남들보다
electrics
먼저
and
획득하기
electronics
위해서
to
노력하고
identify
있습니다.
their partners and access new
독일이라는 기술
technologies
경쟁력의
ahead of others.
한복판에서 고분분투하는
Germany is the
센터
battlefield of
입주
technology
기업에 대해서
competition,
관심을
and there are many Korean
가지시고
tenant companies striving to
자동차,
secure
기계, 바이오
their
분야에서
rightful
우리
place in
기업의
the
표준을
market.
우리 기업이
On that note, I ask
미래에
for your keen interest in
글로벌
this
표준을
regard.
선도할 수 있는 날이
And in
오길
automobile,
많은
machinery,
도움과
BT, and other
도움을
fields for Korean companies to
부탁드립니다.
become leaders in standards, your
혹자는
advice
4차
and support would be
산업혁명 시대라고
greatly
얘기를
appreciated.
하는데 이런
People say that
혁명과
we're living in
번영의
the era of
시대에는
the fourth
반드시
industrial
이것이
revolution.
도전이 되지만
In innovation-driven
또 하나의
society,
새로운
of
기회가
course,
될 수
these
있다고
issues could
생각합니다.
become a
이런
challenge, but at the
새로운
same
기회를
time could
잡으려고 하는
offer
우리 기업들,
opportunities.
특히 독일과의 협력을
Especially
위해서
these Korean
노력하는
tenant companies who
기업들을
are
좀
trying
기억해
to
주시고
work
도움을
in
많은
cooperation with the local German
합니다.
companies. We
또한
ask
독일
for
기업과
your
기술협력에
support.
대해서 필요하시거나
And in
궁금하신 점이
closing, if you're
있다면
interested
저희
in more
한독
information about
기술협력센터를
German
기억해
companies and
주시면
technology
그리고
cooperation,
저희에게
please do
문의해
remember
주시면
our
상심하는
center
것
and please
도와드리겠습니다.
contact us
하겠습니다.
directly for any
감사합니다.
further support. Thank you very
네,
much.
말씀 감사합니다.
So thank you very much. We were able to learn more about your center and the example that you took about coffee. That was such an interesting case. Thank you.
Next, we'll hear from Mr. Alexander Matthews, Senior Researcher at VDE Institute. He will be speaking about cybersecurity standards and conformity assessment in smart technologies. He will again join us online.
Hello.
Hello, good morning and good afternoon.
Yes, please go ahead.
Okay. Okay, Yeah, then please the next slide. Yeah, my name is Alexander Matthäus. I'm from the VDE Test and Certification Institute. The Test Institute in Germany was founded in 1920 with worldwide activities with more than 100 tests per year, mostly in the view of safety, electrical safety, and EMC. And I'm working in the Department of Smart Technologies. This was founded in 2012. And we do assessments of information security of smart home systems, IoT systems, medical technology, and Industry 4.0 systems. We do conformity tests and penetration tests in our laboratory in Offenbach. And we got also DEX accreditations from the German accreditation body for the Test Institute itself, and also for a special cybersecurity standard, the IEC 62443-2-4-2. So my name is Alexander Matthäus, as you see, and since 2012, I'm in the Test Institute. Yeah, next slide, please. Thank you. So we are talking about information security, cybersecurity, which is related to many domains and subjects. So we are coming from the smart home domain. We did tests there since 2012, and we are quite experienced in that. So, but we also expanded the tests to medical technology, to automotive, to Industry 4.0, and IoT in general, Internet of Things with connected appliances and all this stuff. And on the next slide, we see some challenges for the information security. This means they're all the same. We need to adapt to these challenges. This one is confidentiality. We need to protect the secret information. We need to make sure that the data is integer, so that the integrity is remained in the transport. Otherwise, we cannot trust the data. And of course, the systems must be up and running. Otherwise, we cannot use them. And this is the availability that needs to be kept active. So these three challenges are all the same for information security or cybersecurity. And many standards, they represent these challenges, and they really refer to these challenges and go on its way to ensure that this is kept up. Next slide, please. So why it's important to have information security up and running, so that we need to test also this cybersecurity according to standards. So there is this Federal Office for Information Security, the BSI in Germany. It's a governmental agency, and they identify attacks and vulnerabilities for industry and for companies and the overall status. And they give periodic status reports for that. And they identified ransomware attacks as the biggest threat in 2021. One slide ahead, please. There are 144 million malware variants that exist there in 2020. This is a plus from 22%. And the BSI reported already 14.8 million incidents in this year, all alone in 2021. For IoT systems, the BSI identified that there's a great risk and a big threat for the IoT devices which are out in the field connected to the internet, which could be transferred into bot systems for denial of service attacks. So DDoS attacks, distributed denial of service attacks. So we see there's a lot of things going on. Now we go in the next slide to some ransomware details. So this is really the attacks that have the most success right now in these days. This is because they're very structured-like attacks. So the groups, the criminal groups, they have company-like structures. There are managers. There's a technical department behind that. There are also service support department behind that, and freelancers who really work out the day-to-day work. They attack companies. They attack personal, private people, and so there's a real criminal business model behind that. There are different approaches to get this money on a criminal way. On the one hand, there's blackmail for this encryption Trojans, where the data is encrypted and only the release key is given out if there's money, more or less in bitcoins, is paid. Then they get the encryption code again. They also collect hash money so that no publication will go out there if the vulnerability is known. They also collect protection money, so they threat companies that it will shut down the complete service with denial of service attacks. And if data is stolen, they will also try to sell this. So there are a lot of approaches to get money, and this is done actually the whole time. One slide further, please. And here we see also a chart how much for these ransom attacks, how much blackmail money, how much ransomware is collected here. And you see a rise in the average and the median payment of this ransom money. Next slide, please. The attack vectors, how these attackers get into these services and systems, is by phishing. So this is emails which are forged emails to try to convince the user to execute some software or to go to a different link. And then the attacker installs some internal programs. And from there on, the attack starts. Other thing is remote desktop with a remote desktop protocol. Some of these ports are open in the internet and they can be used, can be brute force. So with weak passwords, these remote desktops could be just reused. And there are still some software vulnerabilities that could be used by criminal attackers. Next slide, please. So, but we can do something about this. So this needs to be organized, and it needs to be seen that there are measures available to counter-attack and to prevent these attackers to be successful. Here's a kind of a cybersecurity overview for operation of systems. On the one hand, we have on enterprise level, we have cybersecurity management systems, which are used to establish a management system to really take care about cybersecurity. There needs to be some kind of monitoring about this, and periodic risk analysis needs to be performed for this. Then we have the monitoring of the network itself. So we need to have to establish some kind of incident management into that we can really see, and it can be detected if some attacks will happen. Here, updates needs to be updated, it needs to be installed here in the systems, and needs to be checked regularly. And for the product maintenance, there needs to be processes and procedures must be established to create and to roll out security updates on the different machines, on the different devices and services. Next slide, please. For the developers, this is nearly the same picture here, but it's a bit different approach. For the development, the manufacturers need to see that they have to produce a secure device. And for that, they need to have also a kind of a management system. So from the beginning on, from principles, they need to have a kind of a structure how a secure device and system can be developed. And there are also standards to help them to establish this management system. There's on one hand the ISO 27001 for a management system, and there's also this industry standard IEC 62443 chapter 2.1, where these principles, where this management system is described in requirements for this. Then for the security development itself, the middle part, there are rules for the design, for the implementation, and also for the testing of the products themselves. Also, there are standards available. And further down, for the product security of the products, of the devices, there are several standards also available. Just one click further, please. We see for industry products and IoT products, there are these two standards available, the IEC 62443 4.2 and the new ETSI EN 303645. The ETSI is a basis standard, cybersecurity standard for IoT consumer products. Next slide, please. Yeah, okay, next slide. And there are several security standards available. As you can see, we have some information management systems standards there. As already mentioned, the ISO 27001 and the IEC 62443, Chapter 2. There are development processes standards, and sometimes there are also protocol-specific standards available. For example, here the Energy Smart Grid IEC 62351 for the protocol IEC 61850. These are specific. There are several standards out there, and they list specific requirements for the different protocols. Also, there are product-based standards available for several product groups. The mentioned IoT ETSI-EN 303645. This is the basis standard for cybersecurity for IoT consumer products, and the IEC 62443 for industry components. There are several chapters and sections included there. The 4.2 is for components for industry automation systems. What we also see is the development that the requirements of cybersecurity will be spread into other product-specific standards also. So, for example, there is the IEC 60335.1. This is for appliances, household appliances. This is a safety standard. But now with the new edition 6, there's an NXU is also introduced. And this, on the first time, introduces some requirements for security. When these appliances connect to the internet for updates, for example, so these security requirements must met in the future. Not quite yet, but there are preparations for that. So there's in the future, these appliances need to fulfill also some kind of cybersecurity requirements. Also, there are standards for methodologies. So, for example, the common criteria, the 15408. This is a criteria to have an assurance level to test different systems to ensure the security of these systems. And right now it's worked on quite a similar approach there in the EN 17640, where there's a specific time set before the start of the testing, and for a certain level of assurance testing, this security methodology can be applied. But the conformance will be set with other standards, for example, the ETSI-EN 303645. Next slide, please. So I will go through that a bit quicker, so please step to the last thing of this slide, please. So we see here an architecture, till point number 7, please. We see an architecture of a smart home system with a central communication unit. We see connections to sensors and actors in the house. We see a connection to the internet with the cloud system, the web application, and also a smartphone application. So next click, please. And then we see here the different attacks on the different elements. Next click, please. And all these interfaces need to be checked, and this needs to be considered for cybersecurity tests. And next click, please. And the next page, So we see here, one back, please. Yes, this one. So we see the different systems and interfaces needs to be checked, and we can do this with different approaches for testing. We can check the communication, we can check the cloud systems, the backend systems, we can check the apps and the web applications. But for a risk analysis and also for a concept to test the systems, all these interfaces needs to get kept into considerations. So next slide, please. So this is the approach how we test smartphone or smart home or IoT systems. So we do communication devices tests, backend and cloud systems, smartphone apps. So we see we need really to have a complete system tested from end to end. The conformity needs to be secured, and we do with implementation, we do with vulnerability and penetration tests, check if the implementation is effective. This is this kind of assurance we do with our tests here. What we also need to consider is a lifecycle test. So the product, the device, from the beginning of its installation to the operation to maintenance, later on taken out of service, in all these life cycles, the information security needs to be kept up. And this needs to be tested in our test lab if this is the case. Next slide, please. So here's also an analysis of our tests we did for the last 29 IoT projects we did in the last years. So we test these devices, and we also rate the vulnerabilities we find. Here, these are all high findings. There were also medium and low findings, but these are the high findings. And we see here the distribution of what we found here. So 47 of these high findings were based on weak communication protection. So the encryption of the communication was not in a proper way, done in a proper way. So somehow these communication could be eavesdropped and get into there to read out communication information. There was a weak and 10% weak protection of data, so data could be taken out. Outdated software was also 10%, so our software was not up to date, so there were known vulnerabilities with this software. And there was, in 33%, there was a weak access protection. So to access the system, to get into that, this was not protected in a proper way. Next slide, please. So what could happen if such a high finding would be abused or exploited? Someone could access the network, someone could access the equipment, and this is an entry point for this ransomware we saw in the first slides. So this biggest threat for ransomware. So when the attacker could get into this network or equipment, they could install encryption programs there and start their criminal activities. On the other side, if these high findings would be exploited, there is maybe a loss of reputation, and these information could be public, either in the press or in the darknet, where attack campaigns could be initiated from that. On the other hand, if personal data would be disclosed, this could lead to penalties for the companies, because there is this EU data protection regulation, the GDPR. And this could lead to some penalties because the data was not protected properly. Next slide, please. So here's also a slide to see an overview what kind of standards we usually use to test our devices that we get in our lab. We see a part for the smart home and IoT devices. We use our own test and certification approach, which is based on common criteria with our own test specification. We also introduced now the ETSI EN 33645 for tests of IoT devices. For the industry, the mentioned IEC 62443 standard in these 4 chapters, 4.1 for secure product development, and 4.2 for the technical security for IC components. And for this standard, we also DEX accredited. Also for medical technology, there are several standards available, and we test according to these standards. Next slide, please. We realize it's very important for companies also to get more information about cybersecurity. It's quite a new field. So we also provide workshops on the one hand for risk analysis. Most of the standards for information security are risk-based. So you don't compare physical measures, but you have to have a risk analysis to really evaluate possible vulnerabilities and the measures against them. And therefore, we do workshops with the companies. We also do workshops for information security, information in common, and we also develop pre-tests and gap analysis for companies when they're in their development phase. Next slide, please. So we see there are lots of things to be done in cybersecurity, and it's from the first slides we can see there's a real threat against it. So the companies should really prepare themselves and see what they can do to defend attacks. On the one hand, on management level, but on the other hand, also on product level. And here on this slide, we see what is really necessary from the regulative activities, from the from the legislative view. So what is really required for manufacturers, what they need to obey in views of cybersecurity requirements. For Germany, we got here the IT security law, IT Sicherheitsgesetz 2.0, which defines critical infrastructures. These companies who get into this area of critical infrastructures, they have to establish a information security management system, ISMS. And there are also BSI, for this Federal Office for Information Security. They have also some requirements for smart meter gateway, for example. Then there are some European requirements. On the one hand, they mentioned EU GDPR, the Data Protection Regulation, to protect personal data of persons. This needs to be obeyed anyhow. And in 2019, there was the Cybersecurity Act. This is kind of a law which will establish a voluntary EU cybersecurity certification framework. As it said here, it's voluntary right now, and works are going on there to establish this kind of framework right now. There's one special thing for the RED, this is the Radio Equipment Directive. This directive must be fulfilled for equipment which has a radio transmitter included, or also a radio receiver. And up to now, there are 3 chapters which are regarding to cybersecurity, 3.3D, E and F. D is for protection from harm for the network or misuse of network resources, E for privacy, F against fraud. And these chapters, they were ignored up to now because there were no standards or requirements behind that. But the European Union, they will have a delegated act, it's kind of a law, and they will publish this year. So these 3 requirements, which will lead to cybersecurity requirements, they will become active in 30 months from the 1st of January of next year. So there are 30 months later on, they will be available. Now we come to the next slide. Yeah, just a second. So this is very quick. There are some advantages for cybersecurity assessment. Of course, you need to apply to some of the laws, but you get some advantages besides if you introduce cybersecurity in your products and in the systems. Next slide, please, because I want to come to a conclusion here because of the time constraints. It needs to be said that all systems and products that exchange data, for example, via apps, they can be attacked, and they are attacked. And currently, there are only few obligations for manufacturers, but the changes there are foreseeable. We see that the RED will have this delegated act, and that there will be requirements for product manufacturers that they need to fulfill in the future, and also some product standards. They include information security into their requirements. There's the industry standard 62443, which will gain more importance, and also the ETSI-EN 303645 with the basic requirements for IoT systems will get more and more important and will get more and more momentum. We as the VDE Test Institute, we offer various services to help companies to get into the topic of cybersecurity, to get to know the standards and how to proceed with the testing of that. And here in the last line, we see several labels and certification labels we can offer and can issue there for product certifications. Thank you. That's what's it from my side. If there are any questions, please contact me.
네, 발표 함께 하셨습니다. 정보보안
Thank you very much for the presentation. This was about information security. That was the presentation by Mr. Alexander Matthews. Thank you very much. This concludes the technical issues session of the Korean-German Standards Conference. Today, we had a great opportunity to exchange and share information regarding the standardization activities between our 2 countries. I hope that there will be broader participation and collaboration between our 2 countries going forward. With that, I would like to conclude the Korean-German Standards Conference. You can watch the conference online on YouTube. I look forward to having your continued interest. Thank you very much.